All right, 4.8. We're going to look a little bit at this end of chapter 8 or end of chapter 4, section 8, about how do you model sort of the real world data using polynomials. So kind of when are we ever going to use this kind of stuff? When you look at actual sets of data, on anything, they often fall into some pattern, some sort of pattern that we can describe. And if it's a polynomial sort of shape, we can use a polynomial equation to help express that. And then even more importantly, once you have the model, you can make predictions or help solve problems in the future. So it's really a very common thing to be able to take data, try to describe it with some sort of mathematical pattern, and then be able to use that rule or that equation moving forward. So that's what section 4.8 is all about. So this is definitely a graphing calculator sort of thing. But let's talk about what some of the most common polynomial patterns are, I guess, that you can see out there. So some general shapes when we talk about these different sorts of polynomials. Most common, you did this back in Algebra 1, is a linear sort of model. So if you have values that are falling sort of along a line, we would call that a linear regression or a linear pattern. That would be our first kind of polynomial to look at. So linear means they're not changing direction. As one is increasing, the other is increasing. Or as one value is decreasing, the other one's decreasing. They're all going the same direction. So one thing that we think of is we watch when we look at the data for direction changes. So the more it changes direction, usually the higher degree polynomial you're looking for. So look for your direction changes when you look at your data. For a linear, there's really no direction changes at all. It's always increasing or always decreasing. Quadratic, we know a lot about quadratics. We have increasing and then decreasing, or again, quadratic, remember, could obviously be going that way as well, that U shape. There's one direction change. It goes from increasing to decreasing, or vice versa. So when we look at the quadratics, we should be looking for graphs that have one direction change. Cubic, we know what degree 3 looks like. We get those relative max and min points. That would be two direction changes then. It goes from increasing to decreasing, that's 1, and then from decreasing to increasing, so that's 2. And again, that could be reflected as well. So that change in direction, how many times does it go? Also, another thing to look for end behavior for these, pretty obvious. Cubic or odd powers, you're always going to be going in opposite directions. One's positive infinity, the other's negative. Quadratics, they're going the same direction. So that's another thing to look for, is that end behavior. Quartic, when we look at degree 4, so fourth degree polynomials, those are going to have 3 direction changes. So sometimes it's hard for people to tell, is it quadratic or is it quartic, because the end behavior is the same for each of them. But look at your sign changes. You need that sort of W shape to make a quartic. So we change from decreasing to increasing, that's 1 change. Increasing to decreasing, that's 2 changes. And then decreasing to increasing, that would be 3 changes. So the number of times it changes direction will help you figure out what type of polynomial best models that data. Okay, so I want to take a look at a couple graphs of things that have been graphed already. So say it's a scatter plot, you graphed your real data, you took a data study, and you're trying to figure out what model would best fit this data. So what I'm going to do is go ahead and do kind of a curve of best fit through this, so we can talk about it. Now, end behavior, that'll be one hint. So when we look at the end behavior going in opposite directions, so it has to be an odd power. It doesn't really look linear to me, though. It's not making a constantly increasing or decreasing sort of shape. It's changing direction from increasing to decreasing to increasing. So 2 sign changes, that would be a much better model using a cubic. Excuse me. All right, second one, take a look at this one. If I do a curve of best fit, I think most people probably have a pretty good idea what's happening here. Look at the end behavior, definitely an even power because the ends are going in the same direction. Only 1 direction change though. You're going from decreasing to increasing. So our best guess for this one would be quadratic. It's really important that you know what model to choose, because when we look at data and we put numbers in, you have to be able to check and see what it is first before you apply the model. So that's not something your calculator can do for you. It will do a regression equation no matter what you type in. So you have to know which model best fits. All right, so let's try a set of data and see if we can figure out how can we represent this information. So where you go to do this on your graphing calculator, I'm going to move this down here. On your graphing calculator is you're going to go to the stat menu, and you're going to go to edit, and you're going to enter your data in list 1 and list 2. So X is in list 1, Y is in list 2. Now if you have information in your list already, you should clear it out. So use the clear button and then enter out whatever you need. So if you want to enter and do the whole list at once to clear it out, you would go up to list 1, press clear, and then enter, and it'll clear out any data that you have. Don't use delete, because that will delete your list completely, which is not a good thing. Then you have to reset your calculator. So go ahead, pause the video for a second, get your data entered in here, and then we'll talk next about what we need to do. So go ahead, X is in list 1, and then the Y is in list 2. Alrighty, so hopefully you got all your data entered in there. So we have our data in list 1 and list 2. Now we're going to try to see what this picture looks like on the graphing calculator. So I want you to go ahead and go to your window. And we're going to set up the window so we'll be able to see this data when we do our scatter plot. So it looks like for x's, we start at -1 and we go up to 4. So I don't need to have a whole lot on here. So I think I'm going to make this a little bit smaller. So I'll go from -5 to 5. And then it looks like for y's, we start at -10 and we go up to 15. So I better change my y max here so I can see all the points. We'll say maybe -15 up to +20, just so I can see everything. All right, the other thing you have to do to get your graphing calculator to enter or put data on your calc is be able to go to your stat plot menu. So we need to turn our plots on. We have to tell the calculator we want to graph these points. So go to second y equals and turn your plots on. So I just need to turn the first plot on. And then it says type of graph. You have lots of choices. We want that first one. That's the scatter plot. Your x's are in list 1, y's are in list 2. The mark is just how we show our picture here. All right, so we turned plot 1 on. So we're going to check and see what this graph looks like. So x is in list 1, y's in list 2. We talked about that. All right, so double check just to be sure, and I'm going to do this too. Go to your y equals menu and make sure you clear out anything else that may be in there already, because if you have other stuff in there, it's going to be hard to see your graph. So we set the window, we turned our stat plot on, we should be able to do our graph now and see our picture. Okay, so take a look at the data that you have. What we're going to try to decide is what would be the best model to fit this set of data. So looking for sign changes, things like that. So doesn't really look linear because we definitely have a curve. End behavior, it's going in opposite directions. So it looks like to me, thinking about direction changes here, going up, going down, going back up, that our best model would be a cubic. So a cubic equation looks like it would best fit that situation. So I think that's the model we want to go with. Okay, so how do we get the graphing calculator to help us find the model then, the equation, the polynomial? So we go back to our stat menu and we go over to calculate. So it's stat, calculate, and then we have all these choices for different regression models. Those are like best fit models. Won't fit every point, but it approximates and then gets one that fits the pattern the best. So we want the one that says cubic regression. So for me, that's number 6. And for my operating system, I just have cubic regression. I'm just going to press enter. You might have some other things that it asks you to, and you just have to go down to where it says calculate. So press calculate, and we want to see if we get the same equation here. All right, so you notice the form up at the top. It says y equals has ax cubed plus bx squared plus cx plus d. Then it gives you those coefficients. So let's go ahead and jot them down. I'm going to go out and round out to the thousandths place, I guess. So I have that full thing. Actually, I'm just going to round to whole numbers because almost all of them are pretty close to that. So we can get a really good approximation of what that data would look like. So my equation would be y equals 1x cubed minus 3x squared plus 1x minus 5. And just for curiosity to see how well that actually fits, if you go back to your y equals and actually enter that in there, so you enter in your x to the third minus 3x squared plus x, oops, not times, plus x, and then minus 5, and go ahead and hit, oh, where did my x go? Insert. Oh my goodness. Struggling today with the graphing calculator here, minus 5, there we go. Go ahead and hit graph. And see how well that curve actually matches up. It's pretty good. Goes through most of those points. So this would be a really strong model for that particular set of data. So we entered on the graphing calculator so we can see what model we think best fits, and then we can use the graphing calculator to help us write that model. So that's kind of our plan here for what we're trying to do to be able to see these. All right, so let's do a set of data then, kind of start to finish. So we're going to do one set of data and kind of talk it through and see in a real situation what kinds of things could happen. Okay, so this is about waste. So looking at the environment here, it says the average daily amount of waste generated by each person in the U.S. is given below. It goes through 1996. This is real data. Includes all sorts of waste and all that good stuff. So this is pounds of waste per person per day. So that's kind of gross. So if you take a look at that situation, those are the values that we have. So first thing that we're going to try to do is see if we can graph it and see what kind of model would best fit this. Now let's talk about scale for a second. Our X values are going to be our years. The Y is going to be pounds of waste. We start at 1980. I'm not sure that I really want to start with typing in 1,980. What else could we do to set that parameter or set that value for X? I think I'm probably going to call that year 0. So if that's year 0, that means 1985 would be year 5, and then 10, and then 11, 12, 13, 14, 15, and 16. I think that's a lot easier way to type that in there. And then we're going to take a look and try to do some predictions. We're actually going to try to use this model then once we figure out what it is to answer some questions. But let's get the data in there first. So a couple housekeeping things. Go back to your y equals and clear out your old equation. You're going to go to your stat menu to edit, and we are going to clear out what's in our list. So remember, you put your arrow up on the list name, clear, and then enter. It'll clear out the whole list. And same thing in list 1, clear, and enter. Okay, so I'm going to give you a moment. Go ahead, pause the video, enter in the X and Y values, and then we'll check back in and see what we can do with that model. Alrighty, hopefully got that all entered in there, so let's take a peek. So we have our data in there. What we have to go back now and do is we're going to adjust our window. When we do this new graph, the stat plot's already turned on, but we need to have the window be appropriate for the data we're looking at. So it looks like our X's will start at 0 and then go up to 1996, so I guess I'll go, I don't know, up to 20 maybe, 16, just so I have a little bit past. My Y's definitely don't need much at all for this one, so I'm going to start this. These are really small increments here. I'm going to start, I think, at 3 and maybe go to 5. I think that should probably be plenty to be able to see what's happening with this set of data. So our plot is already turned on. We don't need to do anything with that. We cleared out our y equals. Let's go ahead and graph, and we get some points that look like that. All right, now, kind of tricky in a situation like this to figure out what's going on. You have to think about what's happening in the world too, maybe the contextual reasons out there why things might be happening like this. So waste increasing for the first part, kind of leveled out in the early 90s there. And if you look at the trend at the end, looks like it's starting to decrease again. And we're hoping in a real situation that that's the case. There's much more awareness about our environment and what we need to be doing, recycling, all of that. There's been a huge push in the last 15, 20 years or so to make that happen. So what we're hoping is that, yeah, it increased, but then it's changing direction now and decreasing, as opposed to continually increasing, which would be more of a linear situation. So if that's our guesstimate, what kind of shape would that be? Well, it looks like it might be quadratic then, if we can agree that we're hoping that it's going back down. So it looks like we're dealing with a quadratic situation here. So we're looking like that's going to be a quadratic. All right, so if it's a quadratic, we need to figure out what model is going to best fit that with the calculator. So we're going to use that then to answer B and C. So we're going to say that this is a quadratic, and we're going to figure out what that equation is, right? So this is just sort of same thing as on the previous slide, but giving us a little space to think and look here. All right, so let's go ahead back to stat then, over to calculate, remember, and we need to find the quadratic regression, which is number 5. So again, find your calculate part of this. For me, I just press enter, and we're going to write out that equation. So notice it's in quadratic form there. We're definitely going to need a few more decimal places for this one, so I'm going to go out to 3 decimal places for writing this quadratic. So y equals, looks like it would be negative 0.004 times x squared plus 0.119 times x, and then the y-intercept, the constant, is 3.593, I believe, if I'm reading this correctly. Yep, if we round to thousands, that's what that would be. So that's our model, that's our equation. So what I'd like you to do is go ahead, pause the video for a second, go ahead and get that typed into your y equals. So we have the equation in your y equals. Alrighty, so now we have the equation in the y equals. Go ahead and hit graph so you can see what that looks like, see how well it fits. And again, these are best fit equations. This one doesn't fit quite as well. It looks like it was tailing off even a little bit faster. Negative a value because it's opening down. We're hoping it's decreasing. Thinking about projecting that model out, it would be awfully hard to get to the point where we have no waste per person per day, right? That would be really difficult, but think about where that would be on the graph. No waste per person would mean y would be 0. So where on the graph would that be? Well, that would be way out at the x-intercept. So hopefully we could get to that point, but pretty unlikely. So thinking about this model is probably the best fit that we've got, but we realize that at some point that model may not fit anymore, depending on what's happening with the real data that we're looking at. Okay, so we're going to try to find out what's happening in 2010. So in the year 2010, we want to figure out and make the prediction for what that y value would be. Well, can we do that now that we have the model? What year would 2010 be as an x value? Well, year 0 was 1980, so 2010 then would be an x value of 30. So if we can substitute in an x value of 30, we should be able to figure out what it would be in 2010. Oops, got to put a 30 in there. So go ahead, type that in. Pause the video if you need to, so you can type that in. And we can see what that y value would be, what our output would be. So y looks like it's going to be, if you can figure out that value, about 3.6 maybe, if you're looking at the arithmetic. So about 3.6, and that would be pounds per day per person. So really important in real situations to make sure that you do your labels so you understand what kinds of things you're talking about. Now, another way that we could have done that, since we have the equation in our y equals, you also could have gone to your table. So we'll take a look at our table and looked for the different years that you need. Now we would need an x value of 30. So I'm going to go back to my table set. I'm going to start my table at 30 just so we can see this. Go back to the table and I can get to that number pretty quickly. Oh, yep, there's that 3.563 or about 3.6 pounds per person. So if you have the equation in there, you're basically doing that red substitution already. Okay, last part. It says use the model predict when the amount of waste will drop to 3 pounds per day. So that means the y value is 3 pounds per person per day. When will that happen? So you're trying to find x. Okay, well, let's use what we know on the graphing calculator. We could solve and actually try to solve that equation putting in a 3. So 3 equals, and then have this whole equation here. So 0.119x plus 3.593. We could solve that for x. We sure could. We could move the 3 over, get it equal to 0. So we can move that 3 over. If we subtracted 3, that would be 0.593. This is a degree 2 equation. We would solve it by quadratic formula, which would be not a whole lot of fun with those numbers, but you sure could do it. And you would get 2 possible solutions, 2 x-intercept points, and we'd be able to actually solve through and figure out what number makes sense for that. But I think it'd probably be easier, instead of doing all of that, can we use our graphing calculator to help us with this? Think about the table here. We even have it right in front of us. When y equals 3, let's look in the table when that happens. Looks like that's happening right in here. It's dropping below 3 when we get between 34 to 35. So for x value of 34 to 35, that's where it's still dropping to that 3 pounds per person. What does that translate to in our scale? What years would 34 and 35 be? Well, 30 years was 2010, so 4 more, that would be 2014 to 2015. Somewhere in that year between 2014 to 2015, it's going to drop to that 3 pounds per person. So if you have the model, you can use the graphing calculator, use your table to help you get a good estimation of when that's going to happen. Kind of a cool way to look at that, looking at that trend. So hopefully that has actually occurred. Hopefully we're still in that downward trend for looking at our data. So the whole idea here is we use a polynomial model. We look at our data, and we can use that model then to predict what's going to happen in the future. All right, so the assignment, I'm going to put this up here just so those of you can jot this down, and then we'll take a look and see if we can find these reasonable models for real sets of data.